Second design job will be design of an irrigation system, and last we'll be studying Indus basin irrigation system. Regarding design of barrage, I'll start with basic introduction, or I'll be starting with definition of a barrage. We all are familiar what is a weir. A streamlined construction across a flow is termed as weir. And if that weir is provided with gates, if gates are installed on that weir is termed as a barrage. Also, more specifically, the term barrage is used for the weir across a river. The term barrage will be particularly used for weirs across rivers. So the second point mentioned here is the purpose of barrage. A barrage is built across a river to divert water, raise supply of water. Divert water, as I said, barrages are constructed across rivers. Their major purpose is to divert river waters into canals. Also, the second purpose mentioned here to raise supply, the level of supply. The water level in river is following certain or is having maximum highest flood levels. Sometimes we need to raise that water, or the purpose of raising that water is actually to divert water. Rivers mostly flow at the lowest reduced levels. The highest flood level of a river is obviously lower than the adjoining land areas. So we need to slightly raise the water level. And there the purpose is fulfilled by construction of a weir or a barrage. We have seen in our hydraulics engineering course that if a weir is installed across a flow, the water level rises. And the same purpose of weir is applied here. Third purpose mentioned here is silt control. Mostly naturally flowing streams, rivers, they are carrying certain quantity of sediments. They are carrying certain quantity of silts. And we generally require or we generally want the minimum quantity of silt is diverted towards the canal. So for that minimum quantity of silt diverted towards the canal, arrangements are made within the barrage structure, which will be discussed later in the design. Fourth purpose discussed here is permanent headworks for a canal. We are discussing right now kind of a canal which is termed as perennial canal or which is flowing in most times of the year. There is another type of canals known as inundation canals, which flow only during high flow season or flood seasons. Inundation canals are having flows only when water level in river has sufficiently rise in high flow season. For rest of the year, there are no flows. For installing a barrage, constructing a barrage, we are making a permanent control structure for a canal. And sometimes you must be hearing the term of headworks also. Headworks are the complete arrangement is termed as a headworks, and this weir with gates is a barrage. And if they have no gates, it is a simple weir. It can also serve these purposes. But installing a gate, we are having a better regulation or a better control than a barrage.
ये soil increase
These students आपस में जो बात करते हैं कहीं और किसी और फॉर्म में
ये फिर देने देने मैंने तो फॉर्मेलिटी करने जा रहा है मैंने फॉर्मेलिटी करने जा रहा
The second slide is giving major components of a barrage. Major components of a barrage mean the blue text is in longitudinal section if a barrage is viewed in its longitudinal section, and if a barrage is observed or seen from a top view, the components are mentioned here in red text. First component mentioned here is main barrage portion. Which is the main barrage portion is most of the times nowadays made of concrete, and it consists of a upstream concrete floor, a crest, upstream and downstream glacis, and downstream floor. Please students See this component again. I'll discuss this component, these components on a sketch on the next slide. The first major component is main barrage portion, which is made up of concrete, upstream concrete floor, downstream concrete floor, crest, upstream and downstream places. You see, it's a schematic diagram, schematic sketch of a barrage. It's not on this sketch. The black portion is the main barrage portion mentioned on the previous slide. The main barrage portion is having an upstream concrete floor, a crest. Upstream concrete floor and crest are joined by a sloping floor termed as an upstream glacis. Similarly, the crest and downstream concrete floor are joined by a sloping floor termed as downstream glacis. This is the main barrage portion. If you see this sketch, in this main barrage portion, a strong material or concrete part is only this floor. Barrages do not have deep foundations like bridges or buildings. Bridges and buildings generally have very deep foundations, whereas talking about barrages, they have they do not have deep foundation. Instead, they have sheet piles, upstream, intermediate, and downstream sheet piles. Sheet piles are steel sheets driven into the ground. They are provided all along the width of the barrage. Here we are viewing barrage in its longitudinal section. From a top, a barrage is visible like this. This is aerial view of Kotri Barrage. Kotri Barrage is the last hydraulic structure on Indus Basin. Talking about in the Indus Basin in Pakistan region. In Pakistan region, the last hydraulic structure on Indus River is Kotri Barrage. So I am showing you showing you an aerial view of Kotri Barrage. In Kotri Barrage, if you see it closely, if you see Kotri Barrage closely, we can see a bridge, a road pavement on a bridge. If we see beneath the bridge is supported on several piers. These piers are supported on a weir. We construct a weir on which piers are constructed, and in between these piers, several gates are installed. These gates are used for raising the water supply level. Also, please, if you see the left and right bank of this river, or left and right bank along the barrage, they are canals. The canals are off taking on left and right side of this barrage. So major purpose of barrage was to divert water. So the diversion of water is, please, if you see, is very easily visible here. Okay, my cursor right now is moving along the river path. A river is obstructed by a weir or a barrage, and that weir or barrage is diverting water on the left and the right side, and the water is diverted into canals. Canals are man-made or artificial hydraulic structures or hydraulic water carriers. They are artificial channels. Rivers are natural channels. In this also you can see on upstream side of the barrage, the water width has increased. We are having a greater water width as compared to the downstream side. On the downstream side, the width of the river is significantly reduced. Please, students, hold on for a few seconds. I have to make a call. Please excuse me. I was telling about the major components of barrage. Main portion is concrete. In longitudinal section, sheet piles were visible on the lower profile of the structure. This sheet pile, if you see, upstream, intermediate, and downstream sheet pile. As I said, barrages do not have very deep foundations. Instead of deep foundation, they are sheet piles. These are steel sheets driven into the ground throughout the width of the structure. Still, these sheet piles may not be visible on this sketch, but along the total width of the barrage, sheet piles are driven on upstream, in the intermediate below the crest, and on the downstream end of the barrage concrete part. And the major purpose of the sheet piles, there are several purposes. Of those purposes, one is to hold the soil beneath the barrage structure, and also it is intercepting seepage flows. If we are having barrage, a concrete floor laid on simple earthen part or simple earthen ground, so moisture will start traveling from the upstream side towards the downstream side, and the moisture path is intercepted by the sheet piles. This depth of the sheet piles is kept such that we are intercepting the moisture path, plus the sheet piles are holding the soil beneath the main barrage portion. Inverted filter is provided at the downstream end of the barrage, or provided between downstream sheet piles and downstream flexible aprons. On upstream and downstream side, I have mentioned is downstream protection and upstream protection. These protections are in form of boulders are laid on upstream and on the downstream side of the barrage to safeguard the structure against any scoring and erosion. Say, for example, scoring occurs just upstream of the concrete floor, or scoring occurs just downstream of the concrete floor. It's a concrete floor laid on ground. There are chances that it may be slipped or it may be overturned. Our main barrage portion of this concrete floor may be damaged, it may slide or it may overturn. So if there are some deep pits on upstream or on the downstream side. For protecting against this covering, upstream and downstream protection in form of boulders are laid. And on the downstream side, an inverted filter is installed. Inverted filter is installed to reduce a phenomena known as undermining. In undermining, whenever seepage flow is occurring beneath the barrage, the seepage flow will be carrying with itself soil particles as well, and those soil particles will be exiting on the downstream side. These exiting particles on the downstream side, they can be retained by a filter, inverted filter. If the soil particles are allowed to flow with the seepage moisture, it will be causing tunnels, or it may be causing piping on the downstream side. The undermining the small microscopic tunnels due to displaced particles are formed. And ultimately, they are weakening the barrage foundation. As I said, barrage foundation is nothing but just a concrete floor. And if the concrete floor is not supported by the soil beneath it, it will be displaced or it can be damaged. Now let's see the components in plan view. Or in aerial view, the base of barrage at extreme ends are termed as under sluices. The space within two piers is termed as a bay, and the base at extreme ends adjacent to canal regulator. On a side where we are having a canal, we have under sluices. And under sluices are separated by rest of the base by a wall known as divide wall. A fish ladder for allowing aquatic life or for allowing fishes to pass through the barrage is constructed. Fish ladder is a channel which is constructed or which is provided allowing fishes to pass through the barrage. If you see this situation, on the crest I have marked a gray line. This gray line is showing position of the gate. If the gates are closed, water level is raised. and raised water level is diverted towards the canal. This obstructed path of water is also obstructing movement of aquatic life, movement of fishes. So some portion is kept within the barrage. In case of Kotri barrage, there is a fish ladder, I guess, within this right divide wall. It's these are two divide walls. The base within the canal, head regulator, and the divide wall, they are termed. This portion is termed as under sluice, left and right under sluice, and within the divide wall, fish ladder or a channel having lower velocity is provided. Water passing over the weir when the gates are open as well. Water passing over the crest of the weir, it is having higher velocities. And sometimes the higher velocities they are harmful or they are sometimes very dangerous for the fish as well. So fish they themselves will find a path where they are lower velocities and they will move from that path. Guide banks and flood embankments. Guide banks for in understanding guide banks and flood embankments, please see this upper sketch. Before construction of barrage, the bottom solid line is showing riverbed level and this dashed line is showing highest flood level in the river. After construction of barrage, the water will raise from the highest flood level or normal flow level. It will be having certain upstream effect which are traveling upstream of the barrage. The length of this upstream backwater curve is length of M1 backwater curve. The M1 studied in hydraulic engineering. On the downstream side of the barrage, water will pass over the Weir crest. Over the Weir crest, or it may form a hydraulic jump and again come back to normal depth of flow. The same concept as we have studied in hydraulic engineering. Please, any questions from that?
सर अंडर स्लूस की समझ नहीं आई और बैक की समझ नहीं आई, ये क्या चीज है?
चलिए मैं इसके बाद दोबारा बताता हूँ. Please, any confusion in regarding this the length of backwater curve? Length is equal to m1. We'll be
No, sir.
further calculating again this length of backwater curve for our design example case. So on upstream side of this weir or barrage, guide banks and flood embankments, they are constructed whose length is equal to this length of backwater curve. And here for barrages, it is in M1, generally on mild slopes, and obviously the water level, the water depth is raising, then the normal depth of flow it's M1. You see this Kotri barrage again. In this Kotri barrage, on upstream side of the barrage, there are banks on left and right of the left and right side of the bank. On left and right banks, there are certain constructions made. These are guide banks. Guide banks are allowing or they are providing a channel, a stable channel which is conveying or which is passing water over the main barrage. The length of these guide banks plus the flood protection embankments. They both lengths are equal to length of M1 water surface profile created in for a particular case after construction of barrage. The difference between guide banks and flood embankments or flood embankments, they are also termed as marginal ones. Their lengths are uh, they are the difference between them is these guide banks are stone pitched, their surfaces are provided with heavy stones, whereas flood embankments or marginal ones are simple earthen embankments. and they are the length is equal to length of backwater curve, as we are seeing in this view as well. After construction of barrage, the water depth has increased, and with increase in water depth, the water width is also increasing. The flood width is also increasing. There are chances that certain areas are inundated due to construction of barrage. These are all major components of barrage which we'll be designing in our further classes. Or we'll be giving 4 to 5 weeks to design of barrage. So, and in this 4 to 5 weeks, we'll be designing barrage for on two major criteria. One is designing barrage considering flow over the surface, considering surface flows. And second part of design will be considering subsoil flows. As we have seen in this sketch, I have told you that the water will be flowing beneath the barrage as well. We need to design this barrage so that it can carry the uplift caused by this seepage flows. It can stop the displacement of soil particles due to the seepage flows with provision of this inverted filter, and it can the uplift pressure is also reduced by providing these intermediate sheet piles. This will the depth of these sheet piles, this will be decided in subsoil flow consideration. The thickness of concrete floor, that will be also decided, or that will be also designed in the second part in this subsurface flow consideration. Regarding overflow consideration, the first part can be estimation of design flood. For our case, I will be skipping that part. Regarding this estimation of design flood, we have a separate course of hydrology in which you are preparing several hydrographs depending upon various return period floods. Second is length of the barrage. We have to decide what will be this total width of the barrage, or I'll be terming this as length of the barrage. And two newer terms mentioned here are retrogression and accretion. We have to consider retrogression accretion for overflow consideration. And last is the barrage profile. This upstream concrete flow level and downstream concrete flow level. The upstream concrete flow level is generally kept at the existing riverbed level, whereas sometimes the downstream concrete flow level is lower than the existing riverbed level. For this case, say for example, our upstream concrete flow level is 582, the downstream concrete flow level, you can see it's lower than that. And the purpose of this is to accommodate this hydraulic jump. The hydraulic jump should be forming either at the toe. The position where my cursor is right now is termed as toe of the glacis, or upstream of the toe of the glacis, or on the downstream glacis. The preferable position for location of hydraulic jump is this. Reason for this is as the hydraulic jump is moving on the downstream side, we may require to lengthen the downstream concrete flow, or we may also require to lengthen the downstream protection. If the hydraulic jump is forming, say, just at the toe of the glacis, we will be deciding the length of concrete floor according to the length of hydraulic jump. We are having several thumb rules, we are having several empirical relations which give us length of hydraulic jump. So the length of downstream concrete floor is equal to length of hydraulic jump, and downstream protection is downstream of the hydraulic jump are further safety measure provided in a barrage. This is decided considering flow and whether the hydraulic jump will occur here or upstream of this, but it should not occur downstream of this. If the hydraulic jump is occurring downstream of the glaciers, they will be further reducing the downstream concrete floor level. So this will be separately discussed as a whole article. The positioning of downstream, a class will be given only to this positioning of downstream concrete floor. Left terms are retrogression and accretion. The students, if you see this sketch, The low sketch, the second sketch, which is saying after construction of barrage. After construction of barrage, on the upstream side, our velocities are decreased. On the upstream side, flow depth for a constant discharge, flow depth if increased, the velocity is decreased. And this decreased velocity will cause settlement of sediment particles. Settlement of sediment particles on the upstream side maybe say just like this. So the water having certain quantity of silt is settled here, and the water which is passing over the Weir crest is now having lesser quantity of silt. And the water obviously passing downstream of the concrete floor, it is having lesser quantity of silt. The water originally, the river flows were originally carrying certain quantity of silt, which is now reduced due to construction of this barrage. The downstream quantity of silt is now reduced due to construction of barrage. So lesser quantity of silt, lesser concentration of silts in the water will make water to carry silts from the downstream side, and it will cause erosion on the downstream side. The river will come, the river bed will be depressed on the downstream side, and it will be elevated on the upstream side soon after construction of the barrage. Or maybe generally it is said during first 20 years of the barrage life, silts are settled on the upstream side, and they are covering or erosion is occurring on the downstream side. And it's a phenomena which we cannot avoid. It will always occur. Even if we